Thank you. So thank you for finding me. And after this rescheduled talk, so I don't know if you looked at the printouts or anything. There was another talk scheduled, and the speaker couldn't make it. So I took the opportunity to take this slot to talk about OAuth, the good parts. Everyone, I hope you've had a good first day of the conference, and I hope that you are not too tired, because this will be quite high-paced going through the important part of OAuth. So who am I? Well, I've been working 10+ years consulting and doing project works in the identity space. I started out with an old standard called SAML 2. We'll get back to that. I'm the author and maintainer of the sustainable SAML 2 packages. Nowadays, I mostly do consulting training and OpenID Connect and OAuth 2. I work for Duende Software, which is the new home of Identity Server. And, well, that's it. So let's start by looking at some history about user authentication and API authorization in web-based applications. I'm starting a timeline on 2005, because that was when we really had the first web-based protocols came around. There were things before that. Windows integrated authentication using NTLM. We had Kerberos that is used in Windows Active Directory and also in the Unix space. But those are specialized protocols where if you use Windows integrated authentication, the web browser needs to know about the protocol details. The implementation of Kerberos or NTLM resides in the web browser. And in the early 2000s, there was a need for something better, more flexible. And SAML 2, SAML version 2.0, was invented together with WS Federation, WS Trust. These are protocols that have flows that are working based on normal web primitives. So a web browser that knows how to show HTML, how to post forms, things like that, can run a SAML 2 flow. There is no need for any specific support inside of the browser for that. But those were very enterprisey standards, SOAP, XML, etc. And something better was needed on the internet in the age of internet-based services, and that's OAuth 2 that came along in 2012. We will also look briefly at OpenID Connect and why OAuth 2 is not a user authentication protocol and not a single sign-on protocol. Jumping fast forward, it says soon OAuth 2.1. I said soon into 2020 for OAuth 2.1. Dominic Bayer said in 2020 that it will be finished this year. He said in 2021 that it will be finished this year. And in 2022, we said that, well, for sure it will be finished this year. I had to look it up now. It's still a draft. But it's more or less complete, so we'll talk about that. Along the line, there's also been some best current practices, BCP documents being published, which are advice on how to use it. And it all really comes down to something similar to that. Have you seen this book, JavaScript, the Definitive Guide versus the Good Parts? I read the right one, JavaScript, the Good Parts, and that's about all the JavaScript I know. And that's all about the JavaScript you need to know to be productive in JavaScript. The Definitive Guide is so much more. And it's the same with OAuth. The original OAuth 2 spec came with a lot of flows that were designed for different purposes. And it's been evolving. There's new security threats that we have to handle, but also new mechanisms, new browser features, things that mean that, well, we can condense it to just the good parts. And that's what I'm going to focus on here. The talk is named OAuth 2, the good parts, but it could as well be named OAuth 2.1 because it's essentially the same. So we will look at why does it even exist? Some typical protocol flows, application architectures, and then OAuth is not a single sign-on protocol. And we will look into why OpenID Connect as an additional layer on top of OAuth is a single sign-on protocol. And then some further reading if you want even more after this talk. So why does it exist? So the problem is that OAuth tries to solve is all about something calling a web service or HTTP API. And why don't we just use an API key? I mean, that's simple enough, isn't it? Well, an API key is simple enough, but it has two drawbacks. One is that once you get many APIs and many client applications, then you have a many-to-many relationship of API keys to maintain. The other one is that an API key is a long-lived secret or high-value asset. And you're now sending it along in every single request. And the more you use something, the more likely it is that someone managed to steal this high-value secret. So if we instead get a token that describes what we are allowed to access, then that can prove to the API that we have the right to call it. So what is a token? Well, a token contains, it's actually one of the good things that came out of SAML 2. So this is a SAML token, a SAML assertion, it's called. It's XML. So I don't remember, it's that verbose thing that was before JSON. But it contains some essential concept that was brought forward into the OAuth world. It contains an issuer and signature. So this is a piece of data that was issued by, in this case, ping1, as an example. And there is a signature in here to prove that it was actually issued by ping1. There is a time window saying that this token is valid for consumption for a limited time. That's why we have the difference to the high-value asset, the API key, which is long-lived. If someone managed to get a copy of a token, then it expires, and they can no longer use it forever. There's a scoping. So that's also a difference compared to just using a general password, that we can say that, well, this token is only allowed to be used on a specific place, a specific audience, or a specific API. We have some information about how the authentication was done. Maybe our API is divided into high-value API surface that requires MFA, and a low value that, well, most of the operations, you can do them with just username and password, but if you want to send money to someone, to an external account, then you need MFA, things like that. And we can add claims, which is some information about a user, arbitrary attributes. And there is actually, within all these extensive things, there is actually a real value that is the thing. So we'll see when we look at JSON formatted tokens that we more focus on the tokens. So tokens was a good thing, and they worked, but SOAP and XML was a very enterprise standards. And remember that there was a company once called Twitter. Do you remember that? And there was this Twitter company was actually inventive and open and encouraged third-party application developers to interact with their services. Remember that was a thing? They initiated this, and Google also heard about it and said that, yes, we want this as well. So what they found out was that in the SAML 2 space and the tokens that exist, they were very enterprisey, and they were around the idea that we have a corporation that rules everything, and we have employees that just work within these boundaries. While OAuth 2 was born on the internet age, where we have a three-part relationship. We have the APIs, Twitter or Google. We have a third-party developer creating some application, and we have a user who is actually the owner of the information. And we want to put the user more in control than SAML 2 allows. And that's why the OAuth architecture, and now I'll be using the terms from the OAuth 2 spec, which is maybe the most natural, not the most natural terms to use. But we will call the API now a resource server, and there is an authorization server. And they typically, or they work together. So if I want to access, for example, imagine I've invented and created this magnificent calendar widget that can display your upcoming day reading from your Google Calendar. So Google has an authorization server that protects the resource of the Google Calendar API. And I've created this client application. Client applications can be browser-based, mobile or native applications, or server-based. And there's an important distinction to be made here. So the assumption is that the clients are not under control of the same party as the authorization server and the resource server. There are, of course, first-party client applications, but the security model doesn't mandate that it is under the control of the same entity. One thing to note about a client is that some of these clients, single-page applications and mobile applications, they run on a device which is under control of the end user, while some of them run on a server in a data center under our control. And we, in OAuth 2 terms, we name them public versus confidential client. A confidential client is something that can keep a secret, like a client secret, which is essentially a password proving who the client is, while public clients cannot keep a secret. If I bundle and install a secret or embed a secret in the package being published on Google Play, of course you all get it when you download it. Then it's not much of a secret, is it? And then we have users or people, or using the OAuth 2 term, resource owners. Which makes sense. So the resource server here is the Google Calendar API, and I am the owner of my Google Calendar data, right? So I'm the resource owner. We can call them users as well. So when someone would be using my magnificent new calendar widget, what they will do is that they will reach out to the authorization server, to Google's server, and say, can I please get a token that allows access to my Google Calendar? And Google will produce an access token, sent back, and then when my widget wants to read the Google Calendar data, it will access the resource using the access token. And this means that in a user-centric flow, my Google widget never ever gets anywhere near the user's Google password. And that is an important thing, that we are allowed to delegate access to, for example, the Google Calendar API without having to give that third-party application your Google password. I mean, in the very early days when they were signing in with Google things or applications, sometimes they try to get your Google username and password. Please enter your main Google password here to us. We promise to behave nice. That shouldn't be done. So users should, of course, not share the Google password with anyone. So this access token now that I got from Google and the Google authorization server, if I am a calendar widget, does it make sense if I have a access token that allows me to read all your emails, write emails on your behalf to someone else, update your Google Drive? No, of course not. We also want a mechanism where we can say that this access token should, well, I created it. I am the owner of my Google account, but I want to get an access token now that just allows reading my Google Calendar. The mechanism in OAuth 2 for that is the scope parameter, where we embed in the access token the scope that is allowed of the API surface that this access token may be used at. Scopes in this protocol standard is just defined as a list of space-delimited case-sensitive string. Order doesn't matter. So it's very flexible. And then it's up to the implementer to decide how do we want to structure our scopes. And remember, the scopes is something between the authorization server and the API. Because they are, let's see here. So authorization server and resource servers are controlled by the same entity. So they make a decision and about what the structure should look like. We can have an example. GitHub scopes, where we have read the user scope, which gets access to the user profile and a lot. User : email, which just gets access to reading the user's email. So we can have multiple levels of scopes. We can also see here that naming is hard. Is it colon or underscore? Is it noun, and followed by verb, user email, or read user? I don't know, but it works. GitHub jumped on this when they were a startup. Google jumped on this when they were already an established larger company, so they have a somewhat more structured approach. Remember, scopes are just case-sensitive strings. Google has chosen to use URLs because they provide a structure to these. And here we have, for example, the Google API com/auth/calendar.read-only, which is what my calendar widget should typically request. So how do we request tokens then? Now we talked a bit about scopes in the background, but when we need tokens, there are, in OAuth 2, there are multiple flows for different purposes, different kinds of application. You might have heard that for mobile applications, you should use one thing. For single-page applications, something else. For server-side application, a third variant. But it comes down to, in OAuth 2.1, that we can just focus on two of them. One for machine-to-machine communication, and one for user-centric applications where a user is present. The machine-to-machine communication is called the client credential flow. There is no user present, and it only authenticates the client. So how it works is that the client application posts a form encoded request with saying that, hey, I'm this client. It uses basic authentication with the client ID and client secret to say, hey, I'm this client, I can prove it. And then it says client credential is the grant type just to indicate what flow it's using. And then please give me an access token that is scoped to API 1. Authorization server responds with an access token and a small JSON document containing the access token, the scope, token type, and the expiry time. And then the access token is typically in JWT format, but it could be something else. OAuth 2 in itself says nothing about the token format. OAuth 2 is just a protocol for the handshake, how to retrieve the token. So at least in the past, if you used Microsoft Azure AD, that it was named back then, to get an access token, the access token to access the MS Graph API was not a JSON Web Token. It was something else. I have no idea what. And it worked because as a client application, I just get a token, I know I can use it, attach it to outbound calls, and it authorizes me to do the calls. But it's often a JSON Web Token because it's a simple structure and it can be self-contained and validated without external API calls by the API. And it can also, there are client libraries available everywhere. JSON Web Token access token contains a header, which should have a type header of AT plus JWT to indicate it's an access token in JWT format. It contains a payload, and in the client credential flow, it's simple. Who issued it? The issuer. And the signature, in the previous example with the SAML token, the signature is inside the token. In OAuth 2, the signature is outside of the token, and it's is actually a more simple approach to signing because it signs the encoded representation of the token, while SAML2 is horrible. I worked for a decade with SAML2, believe me, it's horrible. We have the time window issued at and expiry time, and we have scoping saying that this token is valid for API 1. We have claims, and in this case it just says this token was issued to client 1. The token can be used being transmitted in the authorization header. And the authorization type is bearer, which essentially means that anyone that presents this token can use it. It's like a coin or bill. If you have money, you can use it. Nobody asks where you got it from. Whereas there are other more high security alternatives where you also need to prove that you are the legitimate user of the token. DPOP, demonstration proof of possession. That's the things that are used in healthcare, banking, etc. But for the OAuth, the good parts will focus on just a simple bearer token. So what are the processing rules of an access token? Well, the first one is that, as I mentioned, the format of the token is a private implementation detail between the authorization server and the resource or the API, which means that as a client, I must not in any way try to consume it or read it. I should just forward it as a simple string. On the API side, on the other hand, I of course need to consume it and validate it, and there are some processing rules for JSON Web Token. The signature must be valid, and the signature algorithm must be allowed. The type must be AT plus JWT. Issuer must be an expected value, so you should only trust tokens that were issued from the token service you expect. In some multi-tenanted environment, such as Azure AD, you may have something that is signed by the expected key, because Azure AD has one main signing key that everyone is using. But then it's important to check that the issuer is actually the tenant ID that and the tenant issuer that you expect to work with. Current time must be fit within the time window, and the scope must contain an expected value. If we are API 2, we should of course not accept an access token that only is scoped to API 1. And then everyone is happy, right? Well, and everything is working forever, is it? Well, an access token, one of the advantages with an access token over an API key is that it has a limited lifetime. We usually recommend somewhere between 5 and 60 minutes. So after a maximum of 60 minutes, the token is no longer valid. So how would I know as a client that my token suddenly is not valid? Let's go into API, the HTTP spec, 401 versus 403. What's the difference? What is a 401 and what is a 403? 403 is an authorization failure, saying you're not authorized, but the term in the spec is actually forbidden, because 401, which I would rather have named unauthenticated, is called unauthorized. So authentication versus authorization, the distinction is not always clear, and I'm not sure that I agree with how the HTTP spec used the terms back in the 90s. But this is like the referrer header. That's a typo. The referrer needs to be misspelled because it's in the spec, misspelled, and 401 is unauthorized. So, if I have a token, I call an API a number of times, it works perfectly well, I'm happy with it, and then suddenly I call an API and it gives me a 403. That probably means that I try to access a resource that I'm not allowed to access. I try to use I have a read-only scope for my calendar widget. My calendar widget now tries to update the calendar. That would be 403. So it means better back off and continue just reading the calendar. But then I'm happily reading the calendar and suddenly I get a 401. My token used to work, but now this API says that your token is not valid. What probably happened was that it was expired. And that's one way to handle expiry, is to simply just use it until I get to 401 and then once I get to 401, well, it's a machine-to-machine scenario, so let's just do that client credential flow again to get a new token that is valid for another time. But that means that every hour there is a check that the client is still allowed. So if Google finds out that my calendar widget is really doing something really abusive, they would deactivate it. So after 1 hour, all my access tokens will be invalid and I will not be able to get any new ones. We can also be proactive because there is an embedded expiry time in the token. Can I, as a client, read the token to get the expiry time? Am I allowed to do that? No. So how would I know about it? Well, in the response we got back when we got the token, we have an expires in field. Just because of that, because the client needs to know about the expiry time. The client probably needs to know about the scope where it is valid, but it's not allowed to consume and extract it from the token. I mean, the token format could be something that this client doesn't know about.
But so, from your opinion, it's totally fine to take this return time to react before I would get the 401?
Yeah, I would even prefer that. To do that, to react beforehand. But it depends on, I would say that using the 401 approach is a bit more lazy maybe. But on the other hand, in a modern cloud environment, we need to have retry mechanisms for anything in a reliable application, so we might as well use it for this as well. So there are two options. My choice would be to be proactive. So that's the simple flow for machine-to-machine communication. But what if we have the calendar widget? So once more, the calendar widget is a good example. If I create the calendar widget and I say to Google that I want to be able to read calendars, do you think that Google really gives me access to read everyone's Google calendar? No. They should not, and they do not. So of course, there is more to it when it comes to interactive applications. So when we have an interactive application, we need to not have a token that not just proves what the client is, what client it is that is calling. We also need to prove who the user is that is logged in, so we know what data we are allowed to access. We will look at the authorization code flow, and in OAuth 2.1, we found out as a community that the authorization code flow is the flow to use for interactive applications. If you've heard of any one of the other flows, forget about them. It works for web applications, native applications, mobile applications, single-page applications, everything. It allows the authorization server to display UI, and it does that through a web browser. And it also supports, we can get back to token renewal. So the overview is essentially that a web browser, or the client, being it a web browser or a mobile app something, calls to the client to get access to something. There is a redirect to the front channel, or what we call the front channel, which is essentially the browser. So if you want to use my calendar widget will redirect you to Google, where you interact directly with Google. Now you can type in your Google password if you want, because you can see yourself, you are on google.com. All the user interaction happens, probably if you have an Android phone or any browser, you're probably already signed into Google. And now we are on google.com, so the Google authentication cookies are available. So it can just create a response, write back, and send back. And then there is a back channel phase where we retrieve the access token. Let's look a bit deeper into it. The front channel is a redirect to the authorization endpoint of the authorization server, where we include a number of parameters. What client is calling the client ID? Where do we want the response to be sent back? the response type code to use authorization code flow. What API, what scope are we requesting, the API one? And then we can send along a state that is echoed back. This is important for cross-site request forgery guards. And we have a code challenge, which is also a verifier from proof key code exchange. Should also be, it's an extension that should always be used. Once on the authorization server, the user can be authenticated. But this is outside of the scope of OAuth 2. OAuth 2, as a protocol, just knows about we are redirecting, opening the browser. The authorization server may do anything it wants as long as it can eventually return back. The authorization server might also show a consent screen. How many do read these? Yeah. Okay, so next time you hear about someone who got a Facebook account hacked, they clicked the link, they got a consent screen, and they went right to the yes button. So this says, who is the authorization server? What client are you really are getting what access? What are you allowing this client to do on behalf of you? And this is where, when you are using my calendar widget, this is where you should be careful to see that my calendar widget actually just asked for calendar read and nothing else. And this is also where we bind it to the user. So there is an informed consent and, from the user that, well, I want to share my calendar data with this widget. And then we click yes. Once we have clicked yes, there is a return. And so Google now will store away the result of the authentication, user authentication, the result of the consent, store it in a database or data store somewhere, and just return a code which is a key into that storage, and echo back the state. Then our client application can make a backchannel request where it authorizes itself using, or authenticates itself using basic authentication, saying, hey, I'm the client, this client ID with this client secret. That means if someone steals the code here, the code is useless. You can't get an access token just from the code. You also need to be the right client showing your client secret to get it. And we have the code verifier, which is also a kind of a one-time password that is sent. Well, the authorization server is happy, and it returns back the access token that was received. So let's look at what the access token would look like this time. A user-centric access token contains not only the client ID, but we also have a new claim subject identifier, which is an identifier for the user. We could also have extra claims in here, like email, things like that, if we want to. But the main identifier should be an abstract thing, a GUID or a number, because it should be a persistent identifier, something that doesn't have to change. And as soon as you have anything that carries any kind of meaning to a human being, someone will have to change it. Divorce. I want get rid of that last family name now, please. Can I have another email address immediately? Yeah, you don't want to have to rebuild all your systems with that. If you have used an opaque user identifier, you are fine. So this is typical access token, and as all access tokens, it's typically short-lived. So what do we do when it expires? Do we ask the user, redirect the user back to the authorization server every hour? No, that would not be a good user experience. We could get away with that for the machine-to-machine communication case, because it's fine for a machine to just keep an eye on the clock and say that, after 55 minutes I need to make another API call and just get a new one. For user interactive, we need a mechanism to get a new access token, and that's why we use something called refresh tokens. So we need something that represents this authorization that is long-lived. But hey, wait, long-lived, that means if someone steals it, they can use it forever, right? So there are two kinds of tokens. Self-contained tokens, like access tokens typically are, means that anyone who has it can just validate it and use it. Reference tokens are essentially just a number which points to a record in a database. So the refresh token is a reference token which is stored on the server, and that means we can remove it. We'll get back to revocation. So if we jump back here, we can actually see that in the token response, we got a refresh token also. So after 1 hour, the client will send in, using its client ID and client secret in basic the basic authorization scheme, say, hey, let's use the refresh token scheme. I have a refresh token here to prove what authorization event or what authorized session. It's not really a session, but prove what I want. Please give me a new access token, and you will get a new access token and possibly a new refresh token back. And as I said, you can revoke it. You can go into your Google account. This is if you have your Facebook account hacked, you unhack it by going in here, finding the rogue application and revoking consent. Because that will delete the refresh token. The next time the client comes back and tries to get a new access token, it will be denied. We can also revoke tokens programmatically. For example, if we log out or uninstall an application, it's a nice thing to revoke the refresh token. So we have two basic kind of scenarios. Machine-to-machine scenario, it's not much to say about that. There are helper libraries available, open source libraries that can help you doing the interaction, but it's not that hard to code yourself either. Interactive applications, there's more to say about it. So if we have a browser-based application, classic server-side browser-based application, we need typically an OpenID Connect or OAuth client library. You don't want to do all the redirects and validations and stuff yourself. You should use a library. We need something for session management probably, if we want to establish a session. We're getting back to that. And we need something for token management. There are open source alternatives. Duende maintains some of them for .NET, but there are other alternatives as well. And we have the UI assets. And in a classic server-side application, all of this lives on the server, and it's fairly simple. Then we have browser-based applications, single-page applications, where all of this lives in the browser. This turns out that if we look a bit into history, we had, for like 15 years ago, cross-site request forgery emerged as a threat when we were using JavaScript more and more, and JavaScript to call APIs. We were just relying on the cookie being sent, authentication cookie being sent along, and it turned out that we had to guard against cross-site request forgery in all our web applications. And IETF's way of solving that was actually OAuth 2 and saying that, well, you shouldn't use cookies for your single-page application. You should use OAuth 2 and let your single-page application in JavaScript be an OAuth 2 client. That looked like a good idea until we found out that browsers, how good they may be, are not maybe the most secure and trustworthy programming environment. Cross-site scripting, anyone? Or even worse, the Spectre bug, where there was actually proof of concept code where one browser tab, JavaScript running in one browser tab, could exfiltrate the memory of another browser tab. For example, to get tokens. So maybe we shouldn't even do this in the browser. What if we say that let's have the single-page application framework do what it's good at. That's the UI. And let's keep the rest on the application server on the server side. And this is the backend for front-end pattern, which is the current recommendation from IETF for single-page applications. So from an authentication perspective, all web applications should be server-side web applications. You may use your favorite single-page application framework to create a rich user experience, but keep the token handling on the server. running in the data center. Okay, so now we've seen how to do server-side web applications. We've seen single-page applications are also, from an authentication perspective, server-side web applications. What about native applications, mobile apps? Well, we can just open the browser. So when we need to authenticate, if my calendar widget is also available for Android, of course, and my calendar widget, when it needs to authenticate, I can't ask for your Google username and password in my widget setup. No, I will have to open the system browser where you can see that you're actually interacting with Google when you enter your password. And this uses the authorization code flow in the same way. So the client, mobile app just opens the authorized endpoint of the authorization server. And when done, we use a custom scheme or claimed URL so that we can redirect back. This is the same mechanism that if you click a Google Maps link on a phone, you won't open Google Maps on the web. You will get because the Google Maps URL is a claimed URL, and the Google Maps app opens up. And we can use that mechanism to allow the authorization server to redirect back to your app with the authorization code. Then your mobile app goes on and it makes a back channel API call to get the token. So that's the different kinds of applications. We have a final thing to look at, and that is OAuth is not user authentication. Remember, if I've done all of this, my app has sent you over to Google, and you've been there, and we got an access token back, but my app, the client is not allowed to read the access token. So I just got an access token, but I still have no idea who the user is. I might want to be able to say, hello, Anders, at the top of the application. So we need something else that is allowed to be consumed by the client app to do that. And that's where OpenID Connect adds. So we do all of this. And now in OpenID Connect, on the back channel, when we retrieve the access token, we will also get an ID token or authentication response. I thought I had a good slide on that. Yeah, here it is. So in addition to the access token, we now get an ID token that is meant to be consumed by the client. So what is an ID token? ID token is a bad name because it sounds like a token, and then people assume that tokens are sent to APIs, but it's not meant to be. It's more of an authentication response. It just happens to it uses a JSON Web Token format, and this time it's standardized. In the OpenID Connect spec, it says it must be a JWT. It contains some information about authentication time, who the user is, and authentication method, which means that the client application can now work on the front channel to redirect to the authorization server where it receives the code. On the back channel, it gets ID token and access token. Now it can validate the ID token because it's allowed to read it, and start a local session and establish a session here. There's a bit more to it as well. In OpenID Connect, it's actually a distributed session. OAuth 2 has no notion in itself about the concept of a session. There is no such thing as a session. It's just you retrieve an access token and use it, which means that OAuth doesn't know about logout, while OpenID Connect does. So OpenID Connect allows you to do a single logout as well, because you establish and have bookkeeping of a distributed session. So that's it, really it, the good part. You have two flows to use. So if we look at further reading, we have 2 is the magic number blog post from Dominic about the 2 flows you should know about and use. And OpenID Connect is the addition on top of OAuth 2, which gives single sign-on and handles sessions. In actual usage, you almost always want OpenID Connect and not just OAuth 2. Because you, as a client application, you want to know who the user is. There's also a security perspective in it here that if you have OpenID Connect, you can be sure what user the access token is for, because they are guaranteed to belong to the same user as the ID token. We have blog posts and some information also about the backend for front-end pattern. This is maybe the largest change that is happening right now, that we should move away from using JavaScript-based client libraries for OAuth and OpenID Connect and move it to the server side. That's another talk, but I can elaborate a bit on it. And one of the huge reasons to do this is how browsers are now starting to block cookies in third-party contexts. So the JavaScript-based part of the standard for interacting with an authorization server relies heavily on hidden iframes and cookies being sent in these hidden iframes. Safari blocks them completely. I don't know if you remember, does anyone have a Safari on Mac and try to log on to Microsoft Teams? It wasn't possible. So now Google Chrome is following along and are starting to roll out also a complete third-party cookie block. So Microsoft actually fixed it. So I tried to demo that a few weeks ago, and suddenly I was logged into Teams. I was so surprised. But still, the old way to do JavaScript-based OAuth simply doesn't work in modern browsers. They are blocking it for anything but a first or same site context. Yeah, so that's the short reading list if you want to do. Actually, the specs are not that bad to read. This is nice ASCII art that describes the flows. They are readable. And there's so much information out there. A lot of the information you can find when you search for this, a lot of the information is actually really good, but there's also information that sounds trustworthy that nearly got things right, but not exactly. If you read the spec, that's the truth. So if you really want to read it, we have the full working group for OAuth with a lot of specs. Best current practices documents is also good to follow along. What is the BCPs currently for browser-based apps? There was a new draft for the browser-based BCP in November. It was published. Philip de Rijk updated it. A much needed and very good update. We have OpenID.net, where they are the OpenID Connect standard, also perfectly readable. So to summarize, OAuth is a token request response framework. The important invention above what we had previously in SAML 2 is that it's designed for the internet era with third-party access, and it's built with user interaction in mind. SAML 2, as an enterprise protocol, does not leave the user with a say at all. The authorization server knows all the resources, knows about the clients, authenticates clients and users, and issues tokens. Authenticates clients and users is also an important point, that a user-centric access token, let's jump back to that, we have a few more minutes. The user-centric access token here, it actually contains both the client ID and the subject ID of the user. So this token proves two identities. It proves who the user is, but also what client is calling. So it's a dual authentication and dual proof. And of course, the authorization server issues the tokens. That is the main trust anchor of the environment. And finally, OpenID Connect is an authentication or single sign-on and session management protocol that is built on top of OAuth 2. So, well, that's it, what I had prepared. We have time for questions. Yes?
The OAuth 2 spec, I believe, had a device code flow for things like IoT devices.
Yeah.
Has 2.1 removed that as well?
So the question was about the OAuth 2 flow, spec had a device code flow for things like smart TVs. It's that flow where you might have seen it. In the early days, apps like Netflix, etc., you had to type in your password using your remote control. And then now they more have like, okay, go to this netflix.com/login or what it says and enter this code, and there's a four-character code that you enter on the device, and then you sign in on your phone, or probably if you are already signed in, you get single sign-on because the browser on your phone. That is the device code flow. It is not deprecated. It's part of OAuth 2.1. We also have the CIBA, client-initiated back-channel authorization flow, which is another kind of specialized flow. It can be used for a call center. If you call your bank, the CIBA flow can be used so you authenticate yourself on your phone and proves on your device that you are really the account holder, so they can tell you about your bank details. So, but these are specialized flow for special circumstances. So that's why I did mention them. So for 99% of the cases, the authorization code flow will work. We had a question here first, and then, yep.
In case of the BFF pattern,
yes.
What's the best practice to pass the user's identity to the downstream servers?
So in the BFF pattern, how to pass the user's identity to downstream servers. So let's do like this. So this talk is like a condensed version of a 2-day workshop or 3-day workshop. So let's go to the 2-day workshop slide deck and go to a slide I want to, which describes the BFF pattern better. Here we have it. Did I pick the right slide? No, I picked the wrong slide. Here's the slide I wanted. So in the icon for front-end architecture, what you do is that on the same host, same origin that the user sees. So if they navigate to app.example.com, on app.example.com you do have a private backend answering, which means you can now have an HTTP-only cookie that authenticates any call from here to here. That cookie can be same-site strict or same-site lax if you want log out to work. But same-site lax or strict, you should also add an extra anti-forgery protection layer for security. Not everyone uses in a modern browser. And then on the private backend, then this would have the access tokens. So typically on ASP.NET, for example, the cookie contains the token, but in an encrypted form. So the backend just decrypts the received token, can read the received cookie, can read out the token, and attach the token to any outbound API calls. And then in the access token, you have the identity of the user. And then depending on configuration, you might want extra claims, such as email address, roles, or things like that to be present in the access token as well. And that's a configuration thing between the API and the authorization server to say that, okay, this API, if we request the API X scope, we also need to put in the roles in the access token because API X needs the roles to make authorization decisions. So one way to view the backend for front-end component is it's like a cookie to token transition gateway or translator. So a final question over here.
In one of the earlier slides, you had, we got the bearer token back, and then we pass it over to the resource server.
Yep.
How does the resource server know for definite that that's coming from the right place? It's not one that I've just added some random scopes to, and then encrypted and sent along. they have to know it's come from the authorization server, not just me, right?
It has to know that it comes from the authorization server, yes. And so the validation steps it takes, I'm just picking up the access token. I'll have to take this one. So this is the machine-to-machine case, but it's the same. Yeah, it looks like we lost the video signal. What happened? No, back. Thank you. It might be when I just flipped change presentations. Okay, so in the access token when we receive it, it contains the encoded format contains the header and the payload in encoded form, and then here's the signature, typically an RSA signature, public-private. So it's signed by the private key of the authorization server, and then so the API just needs to get the public key of the authorization server and validate the signature. And how do they do that? Well, there is actually a very handy built-in thing. This is an OpenID Connect. So let's go to demo.duendesoftware.com. So if we go to this is an authorization server, which is an issuer, demo.duendesoftware.com. It publishes on, let's see if I can get the mouse pointer right. Hey, there it is. It publishes a discovery document at a specific location. If we take the issuer address and add /.wellknown/OpenID configuration, then we should get a discovery document which contains a JAWS URI, which should, I need to zoom out. What language does it think this is? Wrong? What's that? Okay, so which the authorization server publishes its public keys here. So what the API needs to do when it gets an access token, it takes the issuer, adds that well-known address, go find the key document, goes to the header, check what key ID was used, goes to the document in case there are multiple keys published. This one actually publishes 2 keys. Find the right key ID, get the public key part, validate the signature. You're welcome. So it's good to have questions to drive some more slides. But I think we are wrapping up, and I hope you have had a great first day at the conference. I'll be around tomorrow as well, and same time tomorrow I'm doing a talk on future of cookies and what the browsers are really doing, vendors are really doing to mess up cookies for us. Thank you.